Amit, and I'm a server-side developer working with TDD at Wix. And I'm here to talk to you about what I believe is the blind spot of TDD, the world outside of TDD. But first of all, I have a question. Do any of you worked with TDD? Please raise your hand. Please keep your hands up if you still had problems in production. Okay, so I guess not everything is perfect, and that's what I'm here to talk to you about. We at Wix work with a microservice architecture. We started from 10 microservices, and now we have over 250 microservices. We were able to do that by using TDD that also helped us to do continuous delivery. That means that we don't have versions that we work hard in order to send it to our client. We actually keep on deploying every little change we do. It is very, very nice for our customers because they get quick response and we get quick feedback. But working with TDD in a microservice architecture actually makes a lot of stuff more complicated because there are a lot of outside world. What I said is the problem. So before we can jump ahead and talk about the problems, we need to understand what is TDD. TDD is test-driven development. That means that you first write a test, see it fails, that it actually checks something, run it again, do a little fix in order to make it work, and then run it again and see it pass. Only then we start refactoring, making it nice for the next developer that's going to work with it. I believe TDD is great. One of the crucial factors that makes it great is the fact that it minimizes mistakes. Because we don't do all this overhead and we start to develop all this infrastructure in order to do every little change, we only fix the little change that we need in order to make our test pass. We don't have all those bugs that comes from this overhead and all this infrastructure that we don't need, that we think we might need in the future, but we don't need it right now. Okay? Another crucial thing that I believe is great is the fact that you don't need those papers that a lot of time when you go to work on a new system, you get this stack of papers that tells you what the system does. And you start reading them and you understand what the system does. But when you start working on the system, it had nothing to do with what you read. It's something else completely. Okay, so why is TDD helpful in this? Because you don't actually need those outdated papers. What you do is write a test that actually said what the system does. And then, when a new developer will work on a new system, it actually reads the test and understands what the system does. And this is great, because then nobody needs to read those outdated papers or maintain them. But the most crucial factor that I believe is the greatest thing is the fact that TDD helps developers' confidence. When you go to work on a new system, you actually don't need to sit with another developer to help you understand all the little things about the system, because you can read the test, and then you write your new test, see it pass, and that none of the old tests started to fail, and you actually know what you did works. And this is really, really great. But this confidence actually sometimes leads to overconfidence, what I call the end-to-end overconfidence. When I say end-to-end overconfidence, I mean that your system works great. It works exactly as you wrote it. But in production, everything fails. And this is kind of sad. This is the end-to-end overconfidence. But to understand why do we have this overconfidence and we fail in the end-to-end, we need to understand what kind of test we do. Of course, we do the unit test. The unit test checks every little thing in your system. It checks it very carefully. It checks weird scenarios, things that are hard to write. Most of our tests are unit tests. But we also need to understand how a service works with another service. This is our integration test. That checks the connection between our service and another service. And there's also the end-to-end test. This checks the entire flow of our system like a black box. Okay, so if we have all these tests, it's nice. But there's also those tests. I guess those are the end-to-end tests, because actually our service talks to another service, which talks to another service, and this is the entire flow. But usually it's not only those systems. There's another system, and this is actually the end-to-end scenario. And you can go on and on and on until you can actually write the scenario that the user actually experienced. This would happen when you work in a microservice environment. When you don't have one big system, you have a lot of little services. OK, sorry. So actually, it looks like this. And we can't actually look at it because it's too much. So we don't actually write all those tests because you don't know where to stop. You don't know what to do. You just go stop. We can't do this because you can do more and more end-to-end tests on all those weird scenarios. We don't only do it because we are lazy. We also do it because sometimes we don't know who we're talking to. When you work in a microservice architecture, one of the facts that it helps you is the fact that you don't actually need to know every little thing the other service does. It is not a big monolith. Sometimes the services are outside services, and you don't know how it was implemented. There are a lot of things that can make it so that you don't know what the other service does, and you can't actually write this end-to-end scenario. And there's also a problem with flaky tests. When you write end-to-end tests, there's a lot of problems with networking and stuff that takes time. And actually, many times they fail. And when they fail, you usually run them again and again and again until they pass. And you're very happy when they pass, but you lose all this time. And most importantly, you lose all this confidence, this great confidence that is what I believe is the greatest part of TDD. And there's also a problem that you want to reach the 100%. That's what you do. That's what you write all those tests. But it's very, very hard to reach 100%. Users are very creative about what they can do to our system. And actually, if you are successful in making 100% the same as the production, including all little configurations, this is great, but it's really, really hard. OK. So in reality, at Wix, we usually just do those 3 tests. We do a unit test, we do an integration test, and the vanilla end-to-end test, the test that actually checks our service as a black box. Now I'm going to talk to you about a small imaginary scenario. This scenario is totally out of my mind. All the facts I'm going to talk about are not real. Just understand what I'm talking about and not the actual details, because the system is not real. OK. As everybody knows, there's the IBDS. Do you know what is the IBDS?
International Boycott, Divestment, Sanctions.
Yeah, we actually want to boycott Israel. And this is what we do, or not, because we don't actually boycott Israel. Actually, the IBDS is the International Beer Delivery System. It's a system that actually is supposed to help us and not boycott us from the world. It came to be because our nice Israeli bars. Everybody here loves to drink beer. I don't know everybody here. Most people like to drink beer. And we like it to be good beer and cheap beer. The latter, it's very, very hard to get in Israel. But yeah, Wix Meetup is a great place to get cheap beer. But I'm not here to solve the second problem. I'm here to solve the first problem, getting good beer. That's why the IBDS came to be. It's supposed to send beer to the Israeli bars. Our first customer is the British Brewery, because Britain has a lot of great beers, such as the Mad Hatter, the Winter Troll, and the Big Bertha. So we started working with the British Brewery. British breweries work with pints, because this is the imperial system, and we work with liters. OK, it was great. It was a big success. Everybody bought those beers, and all the bars worked with the IBDS. We ran the end-to-end test. Everything works before we deployed it. But then, the American brewery wanted a little slice of our market. As you know, American beer is not like British beer. It's a little bit harder to find good beer. So we went and found the best beer around that everybody would drink. This American beer actually never stopped drinking it. Of course, sorry. It is the Duff beer and the Bender beer. They are great beers. I haven't tried them. OK. Oh, sorry. So, there's a lot of spoilers right now. So, the British bee works with pines, and the American also works with pines. So they said, okay, we already have this API, so we'll just connect to it. But in reality, the British brewery's pint is 568 milliliters, while the American pint is 473 milliliters. And what happened is the Israeli bar got less American beer than British beer. And that they got really, really upset and didn't want to work with us anymore. And you know, when Israelis get less beer than they want, they actually go on strike. And they're very, very mad. They made petitions and everything. So this is why you don't know the IBDS, because of this sad integration story. Now I'm going to tell you about my integration story. It's a little more complex, and it's not as nice, but it's interesting. I was working on a project called Wix-Touch. Wix-Touch enables you to create an online app from your online store in just one click. At the time, we were working on a product to be able to buy those apps using the App Store. To do that, we needed to work with Apple's API. So, as I said, we are working in a microservice architecture. That means that we have little services. We had the apps builder, who actually builds the app. And we have the app manager that actually manage the app from the moment they were created. In the microservices architecture, I was responsible of the apps manager. The apps manager also had its app data, which is database where he holds all the data about those applications. Okay, now things are going to get more complicated. Because we are working with Apple's API, you can check these are fields that Apple needs. We needed to send the Apple Push Notification Service Certificate and the Apple Push Notification Service Certificate key. Those two fields are very complex, and they sound pretty much the same, even when I say it. Okay, so what did we need to do with it? We needed to get the Apple Push Notification Service Certificate key from the apps builder, save it in the apps manager, and at the apps builder request, we needed to return it from the apps manager to the apps builder. That's why we had the database. Okay. So we ran an end-to-end test. We insert the certificate key in the apps data, and we check that we return it to the apps builder. Everything worked, and it was great. But you remember those weird fields, the Apple Push Notification Service Certificate and Apple Push Notification Service Certificate key? And they didn't only confuse me, they also confused the developers down in the apps builder. Because the certificate was supposed to be sent in base 64, and the certificate key was supposed to be sent in UTF-8. But they got a little bit mixed up, so they were both sent in base 64. So there's no problem, because we have our end-to-end test. We checked it, and everything passed. Well, it's not supposed to sound weird to you, because it's the same scenario as we've seen in the brewery case. We expected to get one thing, and we got another. And we act the same as we were supposed to act, we just didn't get what we were supposed to get. So we want to fix it. The quickest fix is just changing the certificate key to start getting it from UTF-8, and then save it in the app data as UTF-8. But when we are working in the database, we usually think about backward compatibility, because it's a very tricky thing. Because actually, if we would do this fix, we didn't do it because this problem. If we do this fix, we have all our data in base 64, all the certificate keys in base 64, and we get the UTF-8 certificate key, and the database actually looks like this, which is very easy to distinguish because UTF-8 is always green and base 64 is also always purple, so we know which one is which, but in reality we can't actually know which one is which, and they're all gray, which makes it really, really complicated to distinguish between them. So we dodged this bullet, and we added the new certificate key. And the new certificate key actually saves the data in UTF-8, and we get the data from the apps builder in UTF-8, and we save it in the apps data in UTF-8, the new certificate key, and the old certificate key in base 64. So our database actually looks like this. We have the old certificate key in base 64 and the new certificate key in UTF-8, and everything is ordered because there are different columns, and that's nice. So we ran an end-to-end test. It was great. Then, after we deployed it, we decided to move back to the new certificate key. We changed all the old certificate key to the new certificate key. Okay? So now all our data is in UTF-8, which is great. This is what we wanted to get to. Okay. Now we run an end-to-end test. Everything passed. And we dodged the bullet with the backward compatibility. It's 6:30 p.m. and I pushed it to production. Everything looks great. I looked at the logs. Everything works. The next day, I went to a conference. I was really excited about this conference. And at 10:30 a.m., I get a call that says to me, "Nothing worked. What the hell did you do last night? Please fix it immediately." Well, if you can understand the situation, when you go to a conference, usually your laptop, your mobile phone battery is drying up really, really fast because all those people are in the same place. I forgot my laptop charger at home, so I needed to beg people to give me their charger. And I needed to fix it, and fix it fast. So, first of all, before we fix it, we need to understand what was actually the problem. The problem was this. I was sending the new certificate key to the apps builder, but the apps builder doesn't know the new certificate key. I imagined it. I created it from some. I created it, and it was supposed to get the old certificate key. That actually means that it didn't get the old certificate key. It got a null pointer exception, and it went kaboom. So this is not nice, and I need to fix it and fix it fast. So I actually reverted to the old ways. I added the old certificate key, and I converted all the data that was in the new certificate key to the old certificate key. Then the database looks like this, which actually made me, I didn't do nothing, I just caused problems. Just a spoiler, a few days later, we actually fixed it. The apps builder started being able to receive the new certificate key, and everything works. But first of all, I want to tell you about the problem I had. So, why did I experience this not nice scenario? It wasn't only because all the tests passed. It was also because the system was in production, and that means that I didn't get any feedback about people trying to use me and it didn't work. The developers were already on the way home, so they couldn't check it themselves. It may also happen in a system that doesn't have a high throughput, or there are not a lot of logs, and you can't actually see problems. And just for life, you should not deploy at 6:30 p.m. It's a bad idea, and it causes problem, especially if the next day you're going to a conference and you actually don't have time to work on it. So many cases that happen like that. So, what have I learned? I learned what I could have, should have, would have done. I could have used more explicit tests. Oh. I don't know. OK. Instead of checking that the response was the same as the response I was expecting to get, that the apps builder got the same response I was expecting, I could actually have checked that it got the certificate key. And if I would check that, it wouldn't even compiled. And I would actually know that something is wrong because I didn't have a field that I was supposed to return. I could have separated between internal and external APIs, external data types. If the new certificate key and the old certificate key were something different in the apps builder and the apps manager, I just would have worked with a different type inside. I would actually wouldn't have this problem at all. And actually, I could have separated between my service and the app data, because even though it's just a database, it's still external to me. I should have looked at it like it's an external thing. I wouldn't have to do all those changes to make it to base 64, to UTF-8, and all those weird changes I had to do in the middle. So decoupling is very, very nice. So what are my takeaways? Just because I have your test agreement doesn't mean everything will work in production. You need to think ahead. You need to think about backward compatibility. You need to think about, even if you solve a problem, doesn't mean that you don't have any more problems. And those tools and developer methods are there to help you. They are very, very helpful. They made my life much nicer. But you need to know that it's not enough. And be ready to handle problems, because they are a part of life. And they actually teach you and make you better for the next time you're trying to fix something. So, TDD is great, but be aware of what you don't test, the world outside. Thank you. Do you have any questions? No?
Why is a British pint more than an American pint? Where did this come from?
Because they're nicer to us. They like more beer.
An imperial pint is 20 fluid ounces. An American pint is 16 fluid ounces. Don't ask why. It's just one of those things.
British can handle their alcohol.
Yes, it's actually alcohol. It's all.
But the easier solution was just take the same price as beer.
Yeah, you just.
It was fine.
It was for 100 with the
In
Israeli.
Israel, they even have like the Elizabeth wine.
Yes,
Something
which is
advanced. It's less than it. It's like arbitrary.
330.
But actually, after the protest, they stopped doing it.
Yeah, it's only like.
Yeah, it's whatever you want. Do you have any more questions? Yeah?
What is the airspeed of an unlock?
Don't go there.
Okay, things that I can answer. Okay, thank you. Now you have another question? Yeah.
Can you go over what you meant by the internal and external data being different? You wanted to separate them?
Yeah. What was the question was? Can I talk a little bit about the internal and external data types? Okay. You probably mean this slide? Yeah.
The middle one from the slide before. This one should have separated between internal and external data.
In database or in between services?
Yes.
Both. Okay. So this is actually just explains it. You see that in the apps builder, what happened was we started receiving data that was also certificate key and also new certificate key. And then we expected it will return the same kind of type that had the old certificate key and the new certificate key. But actually, it's not the same thing. It was a different type. The fact that it had the same field had nothing to do with being the same. So if you would have separated all those, we would do all this decoupling, everything would be much nicer, and we would actually know that it's not the same thing.
So you were using the same fields across all three of these microservices?
Yeah. Actually, the third one is just database.
But
So-
you the suggestion is to look at the interfaces between the
Yeah.
microservices?
Yeah, just say that the apps builder is one interface. So let's say it's apps builder 1. Oh, let's say apps builder, what we get is apps builder send. And we have apps builder return. And we also have apps manager data type. Okay? Now we have 3 data types. We will also have a different data types for the apps data. Everything would be separated, even inside the apps manager. What he receives is not exactly what he works with inside.
And that would have decoupled the database rollback out.
Yeah, it was also we will also decouple this. Okay, thank you.